Right, so today we're doing radicals, operation with radicals. So radicals, the only thing that we've ever seen radicals before was square roots, right? So we've seen the square root, and we've always called it just square root. But a square root is actually a radical, and there's more than just square roots that are available. So there's more than just square roots. So we usually think of that as a square root, but the reason why we're calling it a radical is because in general, there could be different types. So this comes from square root, and again, that's what we're going to deal with for now. We're going to come back to this, though, in Chapter 4, and we're going to do not just square roots, we're going to do third roots, and fourth roots, and fifth roots. So there's other things other than the square root. So we're going to still concentrate on, sorry, I forgot, mixed up. In Chapter 3 is square roots, and then in Chapter 4 we'll come back and we're going to do third roots, fourth roots, fifth roots, so higher power roots. The radical, if you're wondering, this funny symbol came from the cursive R. Do you learn cursive anymore, though? No. You don't learn cursive in elementary school. Okay. Do you know what... Right, so then A, B, C, right? So cursive is, you don't learn it at all?
We did.
How do you read Hallmark cards? How do you read a card when it's written in cursive? Like if you go to the store. Okay, but you didn't know? Not everyone learned it. So yeah, so like if you go buy a card in a store and it's written in cursive, you're like, what does that say? Wow. That's sad. Okay, so we should learn cursive. Anyway, so cursive, the cursive R is like this. So if you go R, that's R. And then you would do S, right? S, so you know A is this one, so that's cursive, right? B looks like this, right? B, so it's cursive. I know, it's weird, right? So cursive. The cursive R is how they came up with the radical. It's just the beginning of the R. And then they straightened it. So it's R, it looks like that. So it's, anyway, so that's radical. It used to be more relevant when you knew what cursive was, but now you're like, I don't know, cursive. But yeah, so it's the cursive R. So it's the beginning of the radical. So if you're wondering where they came up with this weird symbol, it comes from the cursive R, like it's actually cursive R. Anyway, it was more relevant when you knew cursive. So this radical symbol, again, it goes for square root, but we'll come back to third roots, fourth roots, and other roots in Chapter 4. So right now we're doing square roots. So if I had the square root of A plus the square root of A, and I wanted to add those two together, square root of A plus the square root of A is 2 root A's. 2 root A's. That makes sense? Right? It's like if I gave you, so again, this is a side. Okay, that might have been a myth. I wonder, someone told me that before and I thought that was cool. Okay, so if I was to give you A plus A, you know that that's 2A, right? So I'm giving you here, so again, this is on the side, your brain going, oh, so root A plus root A gives me 2 root A's. Make sense? Okay, so if I give you root A times root B, it would be like A times B, but here, because they both have a root symbol, if they both have this root symbol, I can just say, well, you know what? I'm just going to multiply the 2 and then take the root after. Right? So I'm going to do multiply the 2 and take the root after. Does that work? So I'm going to show you on the side here, what if I had square root of 9 and square root of 4? That's the same thing as square root of 36. Is that true? What's the square root of 9? 3. What's the square root of 4? 2. 3 times 2 is? It's the same thing. So they're saying that I can just take the root of each number and then bring them together after. Right? Or I can bring them together and it'll go back and forth. So we're going to use this property back and forth. If I know root of 36, I can break that up to root 9 and root 4. Or if I know root 9 and root 4, I can put it together as root 36. So we'll be using that property that can go back and forth like that. Okay? Does that make sense? So it can be broken up or brought together. So root 9 times root 4 is the same thing as root 36, but root 36 is the same thing as root 9 times root 4. Okay. Division works the same way, so I can do it this way. So again, I'm going to use 2 numbers that we do know. So here, if I said to you root 36 divided by root 9, what's root of 36? That is just 6. Root of 9 is 3, is that right? What's 6 divided by 3? 2. Is that the same thing as, can I just do this and then square root it after? 36 divided by 9 is 2, right? And is this the same thing? So they're all 2. So these are some properties that we're going to use, is that we can break them up or put them together and keep the root on the outside. That makes sense a little bit? Okay, we're going to use this property. So if you don't quite get it yet, we're going to use it when we break it up. So we're going to be breaking it up into, I'll break up a 36 into a 9 and a 4, and sometimes we'll bring the 9 and 4 together and make it 36. We're going to go back and forth with these properties. Okay, so if it doesn't quite make sense yet, we're going to use it right over here. So here, root of 36. Now don't forget what we already know. Root of 36 is just 6. That's just 6, normal. Okay, you should not need your calculator. What we used to do sometimes is we would make you write this part without a calculator. So if we ever did like a quiz on this part, same with chapter 4. We don't do that anymore just because of the wave of tears, and then we have to get the caretakers, and they have to come here with mops, and everyone's crying. You know, it's like, oh, it's a C, and then, you know, all the water damage from the crying. I know. So I won't take away your calculator, but I'm telling you, you shouldn't need it that much, okay? But I won't take it away. It's just that you shouldn't need it that much. So can we do the root of 9 without a calculator? Yes, you can. Can you do the root of 16 without a calculator? Yes, you can. So you shouldn't reach for your calculator. What I don't want you to do is I don't want you to divide it, get a decimal, and then press anything on your calculator. If I see too much calculator work, I know that you're doing it in your calculator, not in your head. So this root means, look, that means I can root the top and the bottom separately. That's this property. So if I have the square root, and look, it's not about neatness, it's more about accuracy. See how this root goes all the way down to the bottom? Remember how I talked about that in yesterday's lesson? I said, make sure if you mean for it to go to the bottom, write it to the bottom. So I want you to square root from the bottom of the 16 to the top of the 9. If you write it messy, look, they're different questions. So if I only wanted the top square rooted, I would write the top square root but not the bottom. Do you see how they're written differently? Okay, so this is to the bottom, which means I want you to square root the 16 and I want you to square root the 9. You're allowed by this property here to do it separately. So what's the square root of 9? 3. What's the square root of 16? 4. Do I want decimal? No. So if you do want a calculator, they're going to give you 0.75, right? And I'm going to be like, hey, you do that on your calculator, you shouldn't do it on your calculator. So right away, you shouldn't be touching your calculator. You should be trying to do this without it, but that's just 3 and 4, 3 over 4, not decimal, right? So all fractions, so no decimals, please. Okay, unless it begins with a decimal. So unless it begins with a decimal. Unless begins with decimal. Does that make sense, right? So no decimals unless it begins with a decimal. So this one, yeah, I gave you a decimal, so you can keep it decimal. Okay, so then here, this one here, look, the root is only on the 9. Do you see how I wrote it differently? The root is on the 9, so that means I'm going to square root the 9, which is 3. And do I square root the 16? No, leave it. And do I go to decimal? No, leave it. Right? So you should not need your calculator. Okay, most of the numbers are going to be small enough that we can do. Sometimes you'll need it, and I'll show you when we need it, but you shouldn't need it all the time. Square root of 25 minus root of 49. This works like the radical, and we're going to use this already. We used this already in chapter 1. It works like a bracket, right? So remember when we were doing parent function? This was one function, and this is another. But they're not functions because there's no x's, but think of it as this is one thing. So you want to do this separately. Yes? It's okay? All right. So here, I want you to do them separately. They're like brackets. Do them separately. Don't do 25 minus 49. So this is not the case where you can make it a big line. The only time we could do that was with multiplication. Okay, so not all together. So this is 2 separate with a minus in between. So do them separately. So this will be 5 with a minus in between. It works like a bracket. Bracket, bracket with a minus in between. So 7. Can you finish that one? Yes, we can. And make sure there's equal signs, so we shouldn't lose any marks for equal signs, right? So make sure that they're wherever they're supposed to be, all that stuff. We don't want to lose any wasted marks. Okay. Now, do you see how this is different? I'm doing the contrast here. That's got the square root on each one with the minus in between, right? This has got the whole thing. Look, 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 look. This goes across both of them. So that works like a bracket. So it's saying do the bracket first, then do the square root. See how this is separate? See the contrast? Okay, different ways of answering it. So this one here, because it's all over, it works like a bracket. So I want you to finish the inside. 25 minus 16 is 9. Then square root of 9 is 3. Right? You see how the order of operation is different. So brackets first, and then do the next. Okay. This one here, you want to do square root of 1, square root of 13, square root of 36. No. No, 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 no. It must be written in improper form. So remember in grade 9, I was like, write everything in improper form, right? All your teachers usually were telling you improper form. This is the reason. It's much more useful when we do upper year stuff. It's always improper. It's much more useful. When you're picturing it, it's good to learn it as mixed, but then after a while you go actually to reduce it and stuff, improper is a bit better. Okay, so I want you to change it back to improper form. So see how the square root goes to the 36? I still want it to the 36. Okay. 36 times 1 plus 13 is 49. Now that's much easier to do the square root of the top and the bottom, right? So what's the square root of the top? 7. Square root of the bottom? 6. Don't go to decimal. Okay? If it's in decimal form, yes, you can do decimal form because it's already in decimal form. So the square root of 0.04 would be 0.2. 0.2 times 0.2. And yes, if you want to do that on your calculator, like I'm just not seeing the decimals, you can do that on your calculator. Okay, that's fine. Okay. Now, another property. If I have a square and a square root, a square and a square root will always cancel. Right? The square and the square root, does that make sense? Right? We've done that before. We've used that kind of, when we square a square root, it's gone. Or a square root of a squared, right? So it cancels it. So then here, do I need to reach for my calculator and go 19 times 19? No. I know that the square and the square root immediately are going to cancel, so then I go to 19. That's going to be a really useful kind of property when we're doing some other stuff later on. When I square a square root, it just becomes the whatever the base is. I don't have to find out what 19 squared is because I'm going to square root it anyway, so don't bother. Just go like that. Okay, next. All right, here we go. Change to mixed radicals in simplest form. So change to mixed radicals in simplest form. We have a new approach. So when I ask you root 18, usually you grab your calculator and go, uh-oh, where's my calculator? Uh-oh, I lent it to someone. So here, usually you reach for your calculator and you get a decimal, right? Don't reach for your calculator. That's what I'm telling you. Sometimes I would be like, no calculators allowed. Again, the crying and the crying. Okay, so I'll let you have your calculators as a comfort tool, but you're not reaching for it. I don't want to see decimal. So this is our new thing, okay? From now on, forever, ever, 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 I want you to write these in simplest form, okay? What's a mixed radical? We always want it in mixed radical in simplest form. So when you simplify or reduce it, we're going to mixed radical. So you're going to learn what this means. Okay, it's a mixed radical. Simplest form is usually what most people say. Simplest form. So let me go back to fractions. If I said to you, so ignore this for a second. If I said to you 17 over 3, and I wanted you to write it as a mixed fraction. Okay, as a mixed fraction. So mixed fraction, what would I do? I would say, okay. How many times can 3 go into 17? 5? Yeah. How much is left over? 2. And you leave the leftover here on top, right? So that's what this mixed radical is. And sometimes some books only say simplest form instead of mixed radical, but it means kind of the same thing, okay? So kind of get you, some people say simplify that or reduce it. Mixed radical and simplest form is kind of both ways, right? So there you go. So here, what I want you to do is the same idea. I took out as many of the 3's as I could from the 17, right? So it's the same sort of idea. Out of the 18, I want you to take out as many of the perfect squares. Perfect squares. Okay? What's a perfect square? 1 times 1 is a perfect square, but it's boring. Okay? So we're going to start with 2. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5, 25. You getting the picture, right? 6 times 6, 36, etc. Is that good? Those are perfect squares. So those are my nice little perfect square numbers. Okay, I'm just going to highlight those here. So in my head, I go perfect squares. Okay, so my perfect square here. So what I want to do is I'm looking for, just like I was looking for how many 3s I could get out of 17, I'm looking for how many perfect squares I can get out of this square root. What's a perfect square that will divide into 18? Divide into 18. Yeah. 9. Okay, so now I'm going to use this property. So if you're like, I'm not sure if I know what you mean, I'm going to use this thing. So 18 is actually 9 times 2. True? You can use brackets or the time symbol. It's not an X. It's times, right? It's not an X. Okay, 9 times 2. 9 is actually a perfect square number. So when I square root the 9, I get perfectly, exactly 3. Does that make sense? Okay, square root of 9 is exactly 3. But I have a leftover of 2. The leftover 2, I'm going to leave it inside of the square root beside it. Just like we were doing this mixed fraction. Right? So you take out as much as you can, and you leave what's left over. That's it. Right? So perfect square from 9 is, the perfect square 9 becomes 3. Right? So I took out this 9, and that became the 3. So square root the 9, make it here, and leave the remainder in there. Does that make sense? Okay, try it again. See if it made sense. So we're going to say, what's this? What's a perfect square that divides into 50? 25. Does that make sense? So I look for the 25 times 2. The 25 is perfectly square, right? So when I take that out and I square root the 25, I get 5. And please leave the leftover 2 inside. So from now on, whenever you get a radical, right, which is a square root at this point, a radical, I never want you to go to decimals anymore. So no more decimals. Okay? Unless the question asks for a decimal. So unless asked. Okay? People always say, do you want me to reduce it? So people say, instead of saying, do you want me to change it to mixed radical or simplest form? Do you know what people say with this one? They say reduce. Okay? Usually you guys think, oh, want me to reduce it? For some reason you think of it as reducing. It's simplifying, actually, but it's the same idea, right? So you're thinking, you always say, you want me to reduce that? It's actually simplest form. I want it in simplest form. You guys usually think reduce in your head. Yes? We're going to evaluate. So all of these are still just simplest form, mixed form. So when we do an evaluate, like these guys here, right, or simplify, we're never going to evaluate. So I'm never going to do this and touch my calculator. That's why I'm like, you actually don't need it for this section. Unless I get really big numbers, like 7 times 7 times get kind of big, but you shouldn't need this, right? So all of these, when I'm doing these, it's simplify. See the instruction on this one? It's simplify. I don't want you to go to decimal. So get it in simplest form, which is why you guys usually think it's like reducing. It's kind of like reducing. Okay, so simplest form. It means you multiply it and then you reduce it, but you're making it simpler, simplest form, but you're not evaluating. You're not going to go to decimal. Right? So never, you basically shouldn't need, you should be like, why am I touching my calculator? Oh, I'm just checking a multiplication. Right? But never go to decimal. If you go to decimal on all these, it's just wrong. Right? And again, I want this mistake. We're not going to make this mistake, right? We're not going to go to decimal. Okay, so again, does that make sense? So this is beautiful to me now, right? I never want to go to decimal unless it's asked for. Here, 8. What's the perfect square that comes out of the 8? Yeah, 4. And then you got the times 2, right? And I'm just going to highlight, so the 4. Does that make sense now? So we're taking out the perfect square 4, make that a 2, and leave the remainder inside. There you go. For this year, I want you to show me this step. Okay? Then next year, you don't have to show it to me anymore. Okay? So some people are going to be like, I'm seeing this in my head faster. For this year, I want to see the step. I like to know your thought process. Actually, by the end of the semester on the exam, I probably won't need the step. Okay? But after we practice, for this test, though, I want to see the step. Okay, I want to see the thought process. That way I can very quickly go, oh, you're taking out the wrong number, et cetera, right? So I want to see the thought process, but later on we can skip the step. So some people will be like, if I see it's 25 and I write 5, you'll be able to do that later. I don't want you skipping yet. Okay, don't skip anything. I want to see the steps for this. Okay, after you do a bunch, you should be sick and tired of me and be like, oh my gosh, I can do this in my head. Right? That's what I want you to be at the point where it's like, I got it. I got the process. I still had some grade 12s, though, who took out the 4. And do you know what the mistake is? What do you think the common mistake is? You take out the 4 and you write 4. I know. And you're just like, and that's a grade 11 mark off my grade 12, right? And so you want to not, I want it to be fast, that when you get to the skipping, you're like, root it, square root it. I don't want you going too fast yet. Okay? And they're taking out the 4. All right, so that's why. So I want you to be like, root 4 is 2, and then when you look at it, that makes sense. Okay, so just slow it down for now, and then yes, I know some people are always like, can I skip some steps? And then not yet. Okay, try it again. Sorry, was that the question? Yeah. Okay, I knew it. Okay, so that's why. So not yet, okay, later, and then yes, I will. By the end, after this chapter, you can skip it by the time we're doing the exam. Okay, if you're like confident and you're good, then yes, on the exam. For this chapter, I just want to see the thought process.
Even in longer questions you would?
Yeah, I'll show you, yeah. Okay, so for now, keep the steps. I just want you to process, and then we can skip it after this chapter. Okay, but for now, I want to see it. Okay, here, 3, 150. What do I do if there's already a number? So you'll see up here, I only had nothing in front, just a 1, right? Invisible 1. Here, what if there's a number? Well, I'm just going to leave that number in front and go 3, you sit in front. I'm still going to reduce the rest of it. It's times. If there's a number in front, you know that's multiplication, right? So that's multiplying, so it's 3 times that. So 150, right away I can see the beautiful perfect square 25. And then I'm going to go 6, right? So I'm going to take out the 25, so keep picturing 25 comes out as 5. So then we're going to go, okay, like this, and we're going to say, okay, I've got the 3 out there. I'm going to go 3, I'm going to leave the 3 here, and then the 25 comes out as a perfect 5, okay? Leave the root 6. This step you can skip. If you want to skip that one, that's okay. If you go, but can I multiply that in my head and go 15? Yes, you can. So here, the arrow where I'm like, yes, that means you can skip that step, so you can go from here to here. So just show me your thought process of what you're taking out of the root, and then if you go, okay, I'm picturing the 5, 5 times the 3 is 15, and do that right away, that's okay. Is that okay? So that part, you can skip that one. Okay, try it again. Okay, here, what's the perfect square that you can get out of 72? Yeah.
36 and 2.
36 and 2. Okay, what if you didn't see 36? So did anyone see a 9? Right? Maybe saw a 9. I'm going to show you both ways. Both ways work. One of them will take an extra step because you're going to have to reduce it one more time. But both ways work. So it's not, don't throw it away if you saw. So it should be 36. Okay? Or, and I'm going to go or. Yeah, or. Okay, or. And then you could do it this way. So it'll be 4. And what if you saw 9? Yeah. Okay, so it's 9, and that's okay. And I'll just show you how to correct it if you did see that. So if you see the largest, that's better, because then you're going to take out the 4, right? I'm going to leave the 4. The 36 comes out as 6. Make sense? And then root 2. Then you multiply the 2 and get 24 root 2. And like I said, if you wanted to, you could skip from here to here. That's okay. Okay, but just be careful. Like, don't skip steps if you're going to do it wrong. Okay? Or, and if you went, oh shoot, I didn't see 36, but I saw 9, that's okay, it's not wrong. You're going to go 4, take out the 9, and you get, when you take out the 9, it's 3. But then the 8, you should be like, oh, shoot. 8 is actually 4 again, right? Look, and I wrote it right above on purpose. Right? 8 we have here. So you should have said, oh, shoot, 8 I can do again. Right? So then you go 4 times 3 would get me 12. And then here, oh, shoot. Sorry, wrote that wrong. I want to take out the 4. So take out the 4. And the exact 4 would come out as 2. Sorry, needed a new whiteout. So then here, the 4 would have come out as a 2, and then you leave the root 2 inside. And then look, 12 times 2 is 24 root 2. So you're going to get there. You just end up, instead of 3 steps, you might have 4. Or instead of 2 steps, you might have 3. Right? So it's not, if you look at it and go, oh, shoot, I didn't see the 8 at first, you don't have to start over, just keep going. Right? So if you don't see the highest power, keep going until this one in here is reduced as much as possible, right? Is as simplest form as possible. So down to the 2. You can't stop at the 8 because you can keep going. And look, I showed you the 8 right above. Right above right here. You go, ah, yes, the 8. I can reduce more. Okay, so do that. Does that make sense? So either one. All right. Try it again. Here we go. And we're going to do this one. So next example. So the instructions can be simplified. We're assuming all answers are always going to be in simplest form now. Okay, so simplest form. So I say it's not simplest form. That means you didn't take out as much as you can. You guys always say to me, reduced? Yeah, reduced. Okay, but simplest form is usually what we say. Okay, so here. When we multiply, the property is that we are allowed to put them together. So I want you to put them together whenever possible. Right? So I don't want them as separate radicals, so please put them together whenever possible. And then look at that and say, can I reduce that? Can I simplest form that anymore? No. Can I take out any perfect squares out of 15? No. No perfect squares go in there. Then you're done, so stop.